Hi, my name is Michael Radyushkin, and this is my lab report for Lab 2, Lines of Charge. The video will go as follows. A brief introduction of concepts, followed by the experiment, followed by the results of the experiment, followed by the code modeling the experiment, and finally, a discussion. The main purpose of this lab is to find how much excess charge there is on a prepared piece of tape using a rod model for the charges instead of a singular point charge as the previous lab was, and we'll find that the charge is 3.063 times 10 to the negative 8 coulombs. Some of the models and physical principles that are used during this lab include vector forces, which is just a magnitude and direction, Coulomb's law, which describes the forces between two charged objects that are equal but opposite to each other, as shown in the bottom left-hand corner, forces due to gravity, negative, neutral, and positive charged objects, and most importantly, the electric field, which is described using two different formulas, either through a point charge or through a rod, which this experiment will use.
And now on to the actual experiment. The system of the experiment is the floating part of tape B as shown in the left. The surroundings in the experiment include tape A, which provides a charge force to the system, and the Earth, which provides a gravitational force to the system. The initial conditions of the experiment include tape B and tape A being positively charged, which will be discussed in the next slide. The floating tape B section being 0.2 meters, and the floating tape section's mass being 2 times 10 to the negative 3 kilograms. The only force acting on floating tape B in the initial conditions is gravity. In the actual experiment, we slowly bring tape A up below tape B. Once we see that tape B is visibly beginning to float upwards, we stop and record the distance between tape A and tape B.
And now on to the results of the experiment. Using the information from the previous lab, we know that the gravitational force and electric force are equal but opposite to each other as the tape is floating and experiences no acceleration, thus no force. And so the magnitude of the gravitational force and also the electric force is 0.00196 newtons. In the experiment, we found that the separation distance where tape B begins to float is 0.04 meters. Thus, using this information and also the rod model for an electric field and not the point charge model for an electric field, we determined that the charge on the tape is 3.063 times 10 to the negative 8 coulombs. This is the code and computational model we used to support the experiment. As you can see, the magnitude of the gravitational force is equal to what was computed previously at 1.96 times 10 to the negative 3. However, the magnitude of the electric force is slightly less. This is due to the fact that in the code itself, I don't actually use the rod model to calculate the electric field. Instead, I find the electric field of every single individual particle, which in this case is represented by the red circles, and there are 50 of them, and then sum them together to produce the net electric field. So as the number of particles at the top increases, the magnitude of the electric force converges to be equal to the gravitational force. So now what assumptions, approximations, or idealizations did we make? We did not ignore air resistance because this is a non-moving object and it is simply just floating. We also did not treat the long tape as though it were a point charge because we are using the rod model. So we did assume that each U-tape had about the same amount of charge and was evenly distributed along the length of the tape in order to use the rod model for the electric field calculation. And now some post-lab questions to end the video. Some possible errors that could have affected the results of the experiment include the handling of the tape causing a loss of charge on both tapes A and B through the fingers, and potentially introducing a force by air on the tape by breathing on it during the floating part of the experiment. So what if I modeled each of the tapes as a singular point charge like the previous lab? Well, as the calculation below shows, the charge would have been 1.86 times 10 to the negative 8. These estimates differ because we are using a different approach in both of them, and the rod approach more closely resembles the real values because we're taking into account all of the interactions of the charges on the bottom tape interacting with all of the charges on the top tape, which increases the value compared to the singular point charge model, and thus having a more realistic and higher value.